All right, boys and girls, welcome back to the drive-through. Hope everyone's having a wonderful day. As always, the drive-through is sponsored by the deli. Hungry? Stop by the deli. Get yourself a roast beef and cheddar cheese sandwich on sourdough toasted with some veggie straws in this month's veggie competition. 2 points for me today already. All right, so this is number 35, actually from 12.4, okay? And the question says, a trough is 16 feet long. See the figure. Its cross-sections are isosceles triangles with side lengths 18 inches. So we have converted those inches into 1.5 feet, okay? The angle between the two sides is theta. Part A, express the volume of the trough as a function of theta and find the value of theta so that the volume is maximized. Okay, here we go. First of all, this is a prism. It is a triangular prism because it has two bases that are congruent and parallel. Those would be the triangles. So the volume of a prism is the area of the base times the height. So in this case, it's the area of the triangle times 16. So really, this problem is more about expressing the area of the triangle in terms of theta. Okay? So I'm going to do my best here to try to help you do that. Let's look at this triangle right here. And let's say I've just come down here and flipped it around and I included an X and an H. So hopefully you remember that the altitude of an isosceles triangle is also an angle bisector. It's also the perpendicular bisector. So my theta has become theta over 2, and my isosceles triangle has turned into two right triangles. I can say that, let's see, opposite and hypotenuse. So I could say sine of theta over 2 is x over 18. In this case, s is 18. Okay. And I could say that, let's see, cosine of theta over 2 is h over 18. Okay? Does everybody agree? So, I know that x is 18 sine theta over 2, and I know that h is 18 cosine of theta over 2. So I can express the area of my triangle as half the base, x, times the height, h. So the area of the triangle is xh. Okay? Well, that is just 18 sine theta over 2 times 18 cosine of theta over 2. So that means I can express my volume as, what's 18 times 18? 254? 324? 300, times 16. What's 324 times 16? 5,184 sine theta over 2 cosine theta over 2. Now, this next step shouldn't be so hard for me to understand, but I had to look at it like I was looking at one of those magic eye paintings for like 8 minutes until I finally understood what the heck the book was doing. It's just turning it from something that involves sine and cosine to something that involves just a sine. Okay, that's what we have to do. So how can we make, well, this kind of looks like this. Instead of theta, we have theta over 2. And instead of 2, we have 5,184. Okay? So it looks like to go from the right side to the left side, I take my angle and I double it. Okay? So what is theta over 2 times 2? Theta. So that's just going to become a theta. I take my sine cosine and I turn it into a sine. Okay, now I took what was a 2 and I turned it into a 1. So I take what was a 5184. Josh, what's half of 5184? 2. There you go. Yeah, 2592. Thank you, Josh. That's why I asked you. All right. Oh, good, Teddy. I'm just joking. So I think this is part of the answer to part A. Let me pause it. All right, we got a remix to ignition going on within the actual video, okay? Because I made a mistake. Whoa, that's a shocker. So notice, this is what I wrote down, and then I went back to the given information and called it 18. So what I have to do is change this 5184 should be 16 times 1.5 times 1.5. And that would be 36. And then notice that when I divided each side by 2, I get volume is 18 sine of theta. And let me just include cubic feet. And now we're back to being good. Okay, hopefully you caught that mistake. I apologize for the time that I have wasted. You'll never get it back. So now we want to identify the angle that maximizes the volume of the trough. Well, what you could just do is just use your great math sense. Where is sine maximized? At theta equals pi over 2, right? Which means if we made this trough a right triangle, that would be the way that we would maximize our volume. Just so you know, if you wanted to use calculus to do it, you would just find the good old-fashioned dv d theta. That's going to be negative, no, not negative. It's going to be 18 cosine of theta. You set that equal to 0. Where is cosine of theta equal to 0? At pi over 2, all the same, okay? So theta equals pi over 2 will maximize volume. Okay, so part B reads this way. Approximate the change from the maximum volume if the maximum error in linear measurement is half of an inch and the maximum error in the angle is 2 degrees. So now we've kind of got to go back to inches. I apologize for that. Now, the area of the triangle, what we figured out using the double angle formula is that the area of the triangle in terms of s and theta is 1/2 s squared sine of theta, okay? That's what we did the double angle formula to figure out, okay? So, that means that the volume is 1/2 sine squared, 1/2 s squared sine theta times h, okay, where h is the height of our prism. It's actually the length of our trough, okay? So dv, our total differential, okay, is going to be, we got to differentiate it with respect to s first. So 2 times 1/2. So s sine theta h ds plus take the derivative with respect to theta next. So that's just going to be s squared over 2 times cosine theta times h. We just treated s squared and h like constants there. Okay? Plus, take the derivative with respect to h, and you just get s squared over, hold on just one second. I need to multiply this by d theta because it's total differentials. Plus s squared over 2 sine theta dh. So just to review, this is the partial derivative with respect to s times ds. This is the partial derivative with respect to theta times d theta. And this is the partial derivative with respect to h times dh. Hopefully you recognize that from your total differential theorem, or equation, I should say. So now we've just got to put in everything we know. Our ds is, what does it say? 1/2 of an inch. Our s is 18. Our h is 16 times 12. Oh gosh, I'm going to act smart. That's like 192. So you would literally just pop in 18 for s, 192 for h. It says the change from the maximum volume, so theta is pi over 2. Okay, ds is 1/2. D theta is, oh, it says 2 degrees. So let's go back and make that 90 and make that 2, and you pop them all in, and you get your final answer to be, and you get dV equals 1,809.216 cubic inches, which is just over 1 cubic foot. Boom.